Welcome to Study Loop.
So we're going to be winding up on the fish problem that we just did in the previous section. So again, we have this archer fish, and it's shooting some drop of water. The mass of the water itself, the drop happens to be 0.3 grams, and the if we change that to kilograms, it's going to be 0.3 times 10 to the or rather 1 grams, 1 kilogram of 1,000 grams. And if you simplify that, you end up getting 3 times 10 to the negative 4 kilograms. That's the mass of the drop that the fish shoots from its mouth. And the purpose of that is to capture insects. So these are insects. We get that the mass of the fish is 65 grams, and we can leave it like that. We don't need it in this problem. This is the information that we're given, and also we're given that the time it takes for the drop to go outside the mouth of the fish is 5.0 milliseconds, and we can change that to seconds by multiplying that by 1 second per. Remember, milli is like a thousand. So if you think about milliseconds, you think about a thousandth of a second. Like a fraction of a thousand. So we have seconds. We have 1 second per thousand milliseconds, and so this becomes 5 times 10 to the negative 3 seconds. That's the information we're given. We want to find the average force, that the fish exerts on the drop of water, on the drop of uh, water. That's what we want to find out. And still, we're going to use momentum in the next page. So this is the information that we're given. We're told that the mass of the water is 0.3 grams. It expels a drop. Okay, it expels a drop. The other thing we need to remember is that the velocity of the water is given by 2.5 meters per second. Okay, and it expels 0.3 grams, and that takes around about 5 times 10 to the negative 3 seconds. So in the next page, we want to find this average force, which we call F average. But before that, you can recall that the impulse, J, is the same as the change in momentum. But then the impulse is exactly the same as the average force times the time. And therefore, if we know the impulse and the time, we can get the average force. The impulse happens to be the change in momentum over the time. When the drop is expelled, the initial momentum is going to be zero, and we don't know what the final momentum is. So the change in momentum is the final momentum minus the initial momentum. The initial velocity before expulsion is this is for the fish. The initial velocity, not for the fish, for the water, is 0 meters per second. And because of that, it means that the initial momentum is zero. So the change in momentum is just the final momentum. And then we divide that by the time. The final momentum is the mass of the water times the velocity of the water, or you can call it the final velocity of the water. We can assign that to this being the same as the final velocity. It doesn't change much. And then we plug in the numbers. The mass is 3, or rather 3 times 10 to the negative 4 kilograms. 3 times 10 to the negative 4 kilograms. And then we want to multiply that by the final velocity of the water, which is 2.5 meters per second. And then we divide that by the time itself, which we did a conversion on from milliseconds to seconds, which is 5 times 10 to the negative 3. And so there's some algebra going on here. you can bring the 10 up, you can bring this one up and simplify it. It just depends on the process you're using, but we get to see that the average force, or what we're calling the F average, simplifies to 0.15 newtons. That's the average force. Hope you had a wonderful time doing the problems in this chapter. One of the things you want to remember is to always keep the variables up until the end before you plug in, and also use visual diagrams as much as you can to kind of try and picture what's going on, lay out what's given, and then try and figure out what you want. In this case, we wanted the average force, and so we use the momentum impulse, which is change in momentum. And so we're given the time, we use that, and we found the average force. Feel free to send any questions or comments, and have a wonderful day. Okay, thanks. Bye.